Our first invited keynote speaker is Professor Liu from University at Buffalo. Zvi Liu is a SUNY Ampere Innovation Professor at University at Buffalo, State University of New York. He serves as the Director of UB Media Forensic Lab and co-director of Center for Information Integrity. Prior to joining UB, Professor Liu held the position of full professor at University at Albany, State University of New York, where he served as a founding director of UAlbany's Computer Vision and Machine Learning Lab. Dr. Liu's research interests span digital media forensics, computer vision, and machine learning. He has published over 190 journals and conference papers. Recognized for his achievement, Dr. Liu has received numerous awards, including the IEEE Signal Processing Society Best Paper Award, the National Science Foundation Career Award, both SUNY Albany Presidential Award and Chancellor's Award for Excellence in Research and Creative Activities, the Google Faculty Research Award, and the IEEE Region 1 Technological Innovation Award. The title of the invited keynote is Combating with DeepFakes. Zvi, please take it away.
Thank you. Thank you, Haiying, for the nice introduction. Can you hear me now? Can you hear me?
Yes.
My sound okay? All right. Okay. So
yes.
Let me share my... Okay. All right. Can you see my slides?
Yes.
All right. Okay. Well, thanks again, Dr. Guan, for the nice introduction. It is really my pleasure to present at the OpenMFC workshop. We actually have collaborated through the DARPA Media 4 program 6 years ago. And, I presented, I believe, probably is not the first or the second one in the workshop. So it's nice to come back. And I think I gave, when you asked for the title of the talk, I gave a vague title. But I think what I'm trying to do here is adding a little bit, talking a little bit more of the new trends, 6 years since we started this work, and some thoughts and observations I have along the line. So the talk, this is not really a formal canned talk, but more of a conversation and, my personal, some of my personal opinions on this, on the development of this research area. So, when I started working on deepfakes 6 years ago, I think a lot of the threats are, the media call this as a real threat to the integrity of our digital information system. But at the time, I was thinking, most of the threats are really hypothetical. We knew at the time the quality of the synthetic media were not very good, and making them is not that easy. But I think 6 years after, today, if I'm talking about that, and I have to change the way I speak of it because the threat is here and they're affecting us. So I give you the quick example. I think this is a fairly recent example, May 21st this year. There's this image circulated on Twitter showing that there seems to be a big explosion in the backyard of Pentagon. Okay. Of course, this is the authenticity of this image is easy to check if for somebody living in DC, you look outside your window and if there's big smoke coming out of direction of Pentagon, this is happening. Otherwise, there's no reason to believe this is the truth. But for all the other people living outside DC and relying on social media like platforms like X platform, Twitter, Facebook, we could, looking at this image, we could well believe something happened there. And it does, cause, about, 200 miles away in New York City at the New York State Stock Exchange, the SP 500s dropped 0.26% minutes after this image emerged on Twitter. Now, 0.26% sounds like a small number, but it means, hundreds of millions of dollars were traded. So it is causing real impact. This is actually one of the, I think it's not the only one, but one of the few incidents actually cause real world financial damages, some real consequences. Of course, I was called by a CNN reporter, a Reuters reporter, sorry, to ask for the authenticity of this image. We run some of the detection algorithm we have developed under support of DARPA Semaphore program, and show that this image is actually AI generated, and more likely it is created using diffusion-based models. And the algorithm also suggests a few places we could focus on and looking for those kind of artifacts. And, if you look closely, you can identify those places. We identify those places ourselves too, because, look at the windows of the building, all the details of the fence, they just look weird. But the problem is, this kind of images created using AI diffusion-based models, if we spend enough time looking at them, they usually will not cause any problem of identifying them as fake. But the problem is the speed and the quantity they're coming to us. The quality probably doesn't change, but quantity is just, unbelievably large these days. So just give you some idea, riding on the waves of the current events in the world, especially the Hamas-Israel conflict, there are tons of fake images showing up on Twitter. And these are just like a small set of images I was involved to analyze. And all these images, videos are created using AI algorithms, but because they're coming to us at the speed and quantity beyond our reasonable attention span, they sometimes easily, bypass us. And most importantly, I think they take advantage of people who are emotionally involved or even like physically involved in the conflict. And they look at those images, their first idea in their mind is not to say, I check this is a fake image or not. It's actually looking at the contents and be influenced by that. There are also various kind of scams on Facebook these days, and again made with help of AI. They come up with magic cures for diabetes, and with Blizzard here working as an advocate of that magic cure, or Kelly Clarkson suggesting a new non-traditional treatment for weight loss, and Elon Musk, promoting a fantastic game that can earn millions of dollars for you in couple hours. All these were made with help of AI, but they are circulating on Facebooks. They are influencing, large chunk of our population, especially, one of the especially dangerous situation is for the older adults. Research show that they use a lot of social media, especially Facebook, to connect with their friends and family. And this kind of fake ads, falsified videos influence them, and they're losing billions of dollars to this problem, according to FBI. So this has become a very real problem for us. It's just in front of us. It's not, a hypothetical problem anymore. It's coming to us. We're going to see worse scenario in the coming years. So I attribute this problem, looking back 6 years, I sometimes ask myself why this happened, why we're seeing this bad level at this time. I think it's probably the answer is we're at the right moment. It's a perfect storm. First of all, this all spearheaded with development in science engineering. We have all this fantastic deep learning, machine learning, AI, generative AI models shown up in the research area. Actually, I should say, even though we talk about deepfakes in the meaning, using its negative meaning, I would, when I talk to a more neutral audience, I would sometimes use AI GC, AI generated content, because I also want to mention that there are positive use of this technology. But, in this case, I think I just use the words interchangeably. The second driving factor of the development is the multitude of easy accessible tools and services that are making this AI GCs for us. Especially, if I give the same talk, even like last year, I will say to be able to do the things I've just told you, you probably need to know at least a little bit of machine learning, how to get the code, how to download them, how to compile them and, run them. This has all changed within a period of a year. I think largely attributed to ChatGPT, OpenAI. Now you have the simplest online based interface where as a user, you just put text prompt and something will generate for you automatically without compiling even one single line of the code or reading any of the the technical details of the methods. So this means that almost everybody can do this now if they have access to internet and they know what they want. And this is exactly what is happening. A lot of people spending time doing prompt engineering to create new images, to use the creative part of generative AI. But this is also, I think, a big source of the current problem. The third of course, is the data source, the widespread of social media, and it's even more deeply interwoven into the fabric of our life. So the social media not only provide a quick channel for us to spread, for somebody to spread this kind of provide a deep ocean of training data, right? So this used to be, if you want to make a deepfake of somebody who's not a celebrity, not a politician, probably very hard. But with Instagram, TikTok, Facebook, all the social platform, data is almost infinite, and that make it easy to make a tailored, specifically designed, orchestrated version of fake media, and spread it quickly to the whole world. The last part, I think, we can never forget that this all is supported by hardware development, and it is actually one of the fundamental driving factor of this whole development. We have the GPUs, but we also have the cloud computing, and this is all behind this development of deepfakes we're seeing. So I think Jim just talked about the White House EO on AI. I'm very happy to see this actually, in this process. I was in a conversation with one of the White House staffers who's behind this, the draft of this EO on some of the issues related with generative AI and AI GCs. And I think that's probably one small factor why the AI enabled fraud and deception was one point that's being highlighted in the EO. So that's great. On the other hand, on the disappointing side, I would say the EO is showing the right direction, but I think it also relies on content authentication and watermarking to combat AI deepfakes or malicious AI GC. And again, this is my personal opinion. If you think about generative AI models, they're like multitrons, like a highly sophisticated transformer, the robot. And watermarking technology is just like a small little mechanism. I'm not diminishing the value of watermarking AI GC, but I think watermarking alone and plus content authentication is now going to be a complete solution. And my biggest question, and this is the whole, I almost spent 80% of my whole career in the past 6 years working in the detection of synthetic media AI GC. Where does that go? So that is my my biggest question. Now, looking back of the 6 years of development, we actually have a lot of we have made a lot of progress in terms of AIGC detection methods. And that's exactly, the state of the art represented by the OpenMFC workshop we have this year. Just compare the 6 years of competition, you can, everyone can appreciate the effort and the development this whole research community have put in, to push forward the frontier of the performance, the robustness, and, the level of explanation we have, use these methods. I always look at the AIGC detection from the I use a main categorization metric as what kind of features are used for developing AIGC detection methods. And roughly speaking, I think there are two categories. The first one is based on, I call them semantic based. And by the way, this is actually one of the original motivation to start a DARPA semaphore program, which is called Semantic Forensics Program. And again, I contributed some ideas for that effort because I see semantic-based methods hold a good, potential to improve the explainability and the robustness of deepfake detection algorithms. So in terms of semantics, this means that we're not directly classify data as real and fake, but instead we look into some deeper reasons why fake is a fake, and I think everybody can understand that a fake is fake because it is not real, which means it doesn't possess some of the important properties of a real media, a real piece of media should possess, right? So that include, physiological properties. If we talk about humans, they have to be like a real human, or the behavior cues, or physics, right? Because everything is taken from a real physical world, so some of the basic physical laws has to be obeyed and followed in the media, and also in real time interaction. If there's something that doesn't reflect the time and place that the thing is supposed to happen, that is also a big cue that the media we're seeing may not be the real ones. Okay, so and there are plenty of that. So there are many long list of works. I just picked two I'm most familiar with because I'm personally involved in these works. We are specifically looking into the eyes. Like one work we have in 2020, detecting GAN generated images, is looking at the reflections from the two eyes. And physics tells us that a real person, the reflection from the iris across two eyes should be pretty similar to each other, while GAN-generated image may not. We also look into physiological cues where the iris, the pupil, which is the opening of the iris, should be circular for a real human. But, again, GAN-generated may not have that regularity in the results. So the semantic-based methods are nice in the sense that, every time we make a decision, we can always accompany the decision with some explanation. But I think on the other hand, the main limitation of semantic-based method is it may not scale up to a large quantity of data, and also its applicability is fundamentally limited to the constraints we put on there. For instance, for an image where the eyes are not clearly visible, or there's no reflections captured in the image, we may not be able to apply any of these analysis methods. So another alternative path is to go the machine learning way or data-driven. So there, we basically use a nice neural network architecture, give the network a lot of training data labeled as real or deepfake. And hopefully after training finished, we'll be able to get a model, a classifier that can give us reliable classification of the input media. So we have seen, this is the current state-of-art detection algorithms, and we have seen a lot of development in that area. I think the development mostly focus on using sophisticated and powerful neural networks, and across the years, we have seen a trend of media forensics researchers borrow ideas from other branches of computer vision, adapt those models to the specific application of deepfake detection, and almost every neural network model you see in other works like object detection, recognition, even like tracking, you'll probably see a version of that for deepfake detection. Correspondingly, these big models need larger data sets and more curated, high quality data sets to support them. So this is actually, there were a lot of huge development in data sets. We contribute one, the first data set, UADF. At the time, we have only, that was in 2018, we only have 49 deepfake face swapping videos. That's the starting point. But coming to today, I think the largest deepfake data set we're seeing usually contains, close to 50,000 of videos with much improved qualities. So I think, the data set is a very important foundation and also a driving force for the development of AIGC detection methods. And I think OpenMFC is also leading that effort, combining all the data set and provide a benchmark. And thirdly, I think, as a consequence, the performance increases, steadily over the years. OpenMFC will have a summary of the results across the past 6 years. But our own observation, my student Yuezun Li did this statistics. Because we developed this CelebDF data set, and so he took efforts of looking into publications of recent years, grab all the performances and compute the average of that and plot a nice, make a nice figure of that. So we're seeing this trend starting from 2020 when the use is only about 50, and researcher deeply connected with this community, with this workshop, I was very disappointed to see the White House EO didn't mention detection as a solution. But by the mean, practically that means, they're not allocating resources to this research area. But on the other hand, looking like more, retrospectively, looking into our own field, is there any promise we haven't delivered yet? Everything happened with two sides of the factors, right? We on one side, I'm disappointed they didn't include us. But on the other side, I do believe there is a reason that we haven't got the due attention we should have got yet. Okay, so these are some of my thoughts. Just take it as a grain of salt. It's very personal, just my observation, and probably not well organized. But I just want to give you my perspective on these problems. I think the first problem is this is the thing I have a lot of discussion with my students and my colleagues, is we do not really have a clear definition of the problem. Like, what do we mean by real and deepfake? Now, it sounds very simple, right? Everybody started with a data set. You label something, we find somewhere on the internet this as a real data set, containing real images and audios, real images, audios, and videos. And then anything we made from a model will be a deepfake. That definition seems to be, self-evident. But I think there's more subtlety, there's more nuance in that definition. For instance, when we say fake, does it mean the whole thing is fake or only part of it is fake? Or does it mean that, the part of the content, if the content has been, processed with additional operations, compression, adding noises, or, cropped out and pasted into some other, will that still qualify as a fake, even though, part of it's real? No, right? Or even, sometimes ask almost like a philosophical question. If you take a deepfake video, okay, I played it on the screen, I record on my screen, use a camera, and then I upload that video. Now, is that video a real one or is it a deepfake one? Now, of course, content-wise, it comes from a deepfake, so we probably should call it deepfake. But if you look at the signal level, everything should look like a real video because it comes from a camera. So this definition problem is one thing we have to solve, because without a clear definition, the performance evaluation will not be well justified, right? And I see a lot of arbitrariness in terms of the definition we give to the labels. So I think that's a problem we have to solve as a community. And I think OpenMFC, by the way, can contribute this a lot, because during the competition, how do we the more information we give about behind the labels, behind the provenance of the data, probably will help us clarify the scope of this problem. I think the second question is, when we're evaluating performance, what is the purpose of detection? That is also very important. I've been asked by, and I didn't have this moment of realization until, a couple of years back, when I was demonstrating a detection algorithm for people from Getty Images. So Getty Images are is a news agency that collecting images and they basically bundle them up and sell. They buy from individual users and sell them to other news agencies like AP. So they were very interested in this work, in the detection work, and but they told, and I have a good conversation with them, and I understand that their use of this algorithm is the ideal case for what we have been developing is for triaging, right? So it's trying to go through, because they have to deal with hundreds of thousands of images on a daily basis. They want to know whether some images has been manipulated in some way, right? But it doesn't need to be very accurate, because they just want to filter out those easy cases. To the very end of the day, they still need human expert to look at that. But looking at 10 images a day compared to looking at the hundreds of thousands of images a day means very different for human experts. But when they actually look at the single images, they said, they don't use any algorithms because algorithm does not give them the explanation. So, and I've been also working in legal cases and investigating journalism, for deepfake evaluation verification. There, they don't care about, how your algorithm works on 10,000 other images. They care about how your algorithm work on this particular image and what explanation you can give to me so that I can put in a story. If I just say, my algorithm tell you this is 99% confidence, this is a fake image, without giving any further information, they would just turn around and not talking to me anymore. So I think it's important to make that distinction and evaluate the performance really depending on what's the end use of our algorithm, whether we're using for triaging or we're using for evidence. The third point I want to make is this is again a recent realization is this is not a sin for us only. This is, I think, applies to the whole machine learning AI community. Is our algorithm is always overconfident and we are always tasking them too much and we give them too little and ask for too much. I give you an example. So these days, very an issue that people discuss a lot is generalizability, right? How do we deal with a model you have never seen, and images you have, AIGC you have never seen, and you train a model, you try to generalize to those AIGCs. And I've been working on that problem, for quite a few years. We didn't get any good solution to that problem. And at the end of the day, I realized we should think about this problem from a different point of view. A lot of you may not agree with me, but this is my thought. I make an analogy, almost like, we train our deepfake detector these days with the types of deepfakes we know for now. That's almost like I'm teaching a class on computer science, okay, programming languages, and I teach my student Python, okay. So that's what I did, and then we task our deepfake detector, train deepfake detector, for a completely different kind of synthetic content. That's like, I tell my student, you study Python, and then the final exam will have something completely different. I'll pick a functional language like Lisp. I believe if for a real human student will protest and probably go to the department and complain that I didn't, I was cheating on them because I tell them to do one thing and then test them on another. But we're doing this for our algorithm, essentially, right? Asking for generalizability, what I would say unreasonable generalizability, is an over requirement. But part of the problem is our algorithm cannot complain. It cannot tell us, I cannot do this. I'm not sure how to handle this. I've never seen this. We didn't simply give them an option to give up. And I think this is the problem we're having. We force our detectors to make decisions on every input, and that is that is causing some of the problem in the performance. That's why we see performance on benchmark data sets looks really excellent, but when we actually try them in the wild, the detectors start to fall apart.
Wait.
Sorry.
So just in case I forgot, actually, I do have some idea about this kind of question, because when we train the model, we use training data. The training data has a boundary. So I think if we have an approach to describe the training boundary, and then when the test prop comes, if it's not fall in this kind of the training sample space, then we can reject. So
yeah, classification with the rejection is one possible solution to this problem.
Yeah.
I do believe that we need to, but at least the community needs to think about this way.
Yes,
because
exactly.
If you read recent papers in this year's CVPR, I still read papers talking about generalizing the algorithm without boundary, without constraints. I think that's that's an over ask. So I'm trying to defend the community to say it's not the performance not good, it's because we asked for too much, right?
Exactly.
And I think right, that's a good point you raised. So by the way, I just want to make sure I'm good on time. So 2:20.
I think so. You give such an amazing talk and it's such an insightful thinkings. Actually, I don't want to cut your time. Just take the time, whatever you need. Then
okay. I should be able to finish by in about 10 minutes. Yeah. Okay. All right. Yeah. Thanks, Hai.
Yeah.
Yep. So I think the third one is there's too much reliance on label data, and we have very little way to diagnose our algorithm. So whatever happened, we're happy with good performances, but we never know what kind of attribute has been learned by our algorithms. This is a criticism more directed to data-driven methods. If we start with the semantic cues, we know exactly what we're trying to learn using the machine learning, the neural network model. But with the data-driven method, that is a black box. We don't know. So I think a lot of the problem of, lack of robustness and, sometimes not generalized even across different data sets, that is probably caused by either model learn something that is only circumstantial, only specific to that particular setting. So that's something we need to look, instead of, just pushing the boundary, pushing the performance higher and higher. I think we should go back and look at the methods and have a deeper understanding what exactly they learned, and are the features they learned actually, have some relevance to the fundamental problem we're trying to solve. And the last one is, I think there's very few user-friendly testbeds for performance. I think OpenMFC, of course, is a benchmark, helps in that way. But these days, we are living basically in two worlds. One is the commercial systems. There's a Reality Defender, there's NVIDIA Verify, and there are a bunch of other commercial services doing deepfake detection, but they're all closed source systems. So we don't know what kind of features they use to do the classification. On the other hand, we have a lot of online open source research code, but they're spread in GitHub, many other different places. So we need to find a way that we can, first of all, make it easier for a user to take advantage of this state-of-the-art detection methods. And secondly, for a researcher, we can do a comprehensive comparison without too much pain. So this is one thing we've been working on, is called DeepFake-O-meter. It was taken down a few months back because we got cybersecurity problems. The new system is online now, but it's still in a beta test. So the link is at the very bottom. So if you're interested, please, help us growing this. But what I've been trying to do here, like same idea as OpenMFC, is building a community. But instead of just being a benchmark, we want to have live code, real running, and being able to compare performance, not just by the numbers, but also by individual examples. So I think there are a lot of ways we can find collaborations in this arena. So now some even wilder thoughts about AI GC deepfake detection. What will be the next steps? I think we should take a broader perspective, and if I fast forward maybe 5 years into the future, I will say we should be well aware that in the future detection of AI GC may not be as relevant as we have today, and that is because even in today's information ecosystem, deepfakes is still a minority. There are a few low quality bad things in the majority of good things. But as the technology developed, especially as I mentioned, AIGC can be used in a positive way. And one of I think the most technical advancement in this area is incorporating AI models into video compression. So streaming video will become an AI problem, where instead of the camera capture my image and compress it as an individual frame, as a video stream, send to your camera so you can see me, there will be a way that it's an AI model of me, it's a neural network model of me, and then you can choose where you want me to be. I could sit in your living room or in your company's conference room to give the same talk. And you can make me wear some other things instead of, just very casually. And I think that's all incorporated into this VR world. In that sense, we are going to see the flip side of the situation where the majority of the contents will be AI generated and real data becomes relatively, rare. So in that case, the question may not be detecting something is AI generated, but probably more likely to be authentication of the use of those AI models. It's like, say you use my AI models on your computer. Is that an authentic, verified use with my consensus of that? And also you want to test do more like a biometrics research community for a liveness test, presence test. Like, are you talking to me, even you talk with an AI, but is that AI driven by a real person behind it? That's myself instead of, somebody else, right? And secondly, I think we need to also look into beyond a binary level. We probably should get more information about the whole lifespan of a piece of media coming to us. The attribution, the provenance of the generation process, what kind of model it has used, what's the detail of the model, how many layers of neural networks, how it was trained, what training data set that has been used. All this will provide invaluable information for the forensic analysis of this, right? Because sometimes I think about this, it's ironic. We call media forensics, but when I go to a forensic science conference, I said, I'm a researcher in media forensics. They ask, what do you do? I said, I detect them. I tell which one is real, which one is fake. And they say, no, that's not forensics. That's like, like you do a real criminal investigation, forensic investigation. You go into the room, find the blood stains. That's only the first step. The real forensic happens. You take that sample, go back to lab, you analyze who that blood belongs to. We have not done that much yet in this community, right? We haven't been able to help law enforcement agencies or investigating journalism to figure out who's using what model and what kind of data are making those deepfakes. So we should actually turn our attention to those questions. And, I think that would make this research area more like a forensic science. I think the third is providing, along the same lines, providing more information, fine-grained analysis, spatial temporal localization, which part of the media has been modified, in terms of video, maybe only a part of it is spicy and the other part are real, and also go across other modalities and also use cross-modality analysis. We mostly talk about images, working with images and videos these days. Audio deepfakes are becoming very, very, are going to be a very important topic in the future. So I think, I hope one day OpenMFC will also have an audio track and, we'll have audio deepfake detection algorithm in it. Last, I think, even though I said generalization is hard, but that doesn't mean we're not working on it. The zero-day attack, even though the detection algorithm may not guarantee a complete solution, but at least it will help us, give us hint that some kind of attack is happening with an unknown model. So that kind of alarming mechanism will also be a big contribution from us. All right. I think there are a lot of things we can do beyond detections. I'll go quick here, but I want to say detection, we have been focusing on passive detection. Basically, we don't interfere with the generation process, but there's recent development where we can do more than just wait there, sit there and wait for the deepfake to show up and run the detector. One idea is to embed perturbations into the training data in a way of contaminate or poison the training data. So somebody got the data, train their model, their training will be stocked or, slowed down. Or we can add those, I call them radioactive markers to training data. So it's not watermark the final AIGC, but it's incorporate those radioactive, almost like the hidden, magnetic stripe in the dollar bill, where you use, but you use the training data to contaminate the training data to train a model. The samples will carry those marks so that we'll be able to see this sample is generated from a model trained using our own data. Okay. And I think even beyond detection, beyond the technology development, there are a lot more in deepfake study. So scientific research, technology development, which is everything I talk about, before this, is one piece of the puzzle. We also need to focus on educating the user and training investigators. I think NIST can play a very important role in that area. And also, the White House, with all of my criticism about it, I think I still support it because it's one sincere effort of making policy and regulations from the current government towards this significant problem. And I think the last is to find economic incentives and creating markets for deepfake detections. Like we have, a few commercial services doing this, but it's still in a very small scale. I mean, I'm just comparing the dollar amount of how much money OpenAI invested in making the ChatGPT and all the generative AI tools, and how much the budget needs to get to support OpenMFC or the research grant I got from DARPA, to do this work. We're not even there rounding errors. We're way under invested. So I think all these are important. I'll just quickly mention that beyond my technical work, we also have an NSF research project providing this learning platform and mobile game to help the older adults to understand the deceptions and scams on social media, including those made with AI. So we have our this talk come at the right time, because yesterday we just launched our mobile game called Deep Cover for the older adults. So but most people can play it too. So you can go, if you go to App Store or Google Shop, just look for Deep Cover. You'll find that mobile game and download and play with it. And I welcome you to give me reports your experience, and if you find any bugs, please also let me know. All right. So in summary, I think deepfakes have developed to such a sophisticated level. It is a real threat to us. And I think there's, you probably get my general take on this problem is there's no silver bullet. We have to work together. It's not like my community against your community, against other people's community. We need everybody to work together. Either you come from the content authentication, or from the watermarking, or from detection attribution, or from the active forensics side of research. We work together to find a better solution. And I think in the future direction, I've talked a lot about that, but I think the most important thing is not to so much focus on the numbers, but more on the explanation, more on the insights we get from the detection methods. And only by doing that, in my opinion, the community can grow and become a mature research area. Yeah, that's all I want to talk about. Sorry, I took a little more time than I was scheduled. Thank you very much.
Thank you, Sui. Thank you for such a wonderful talk. Actually, your topic is just a question I want to ask you. Pre-prepared. I can read this to you. So okay. Basically, as a leading professor, predicting the future is very, very challenging. You gave us a kind of the overview of how we go through from the past to current, and how we want to position ourselves in the future research field. So you are from academic, but you're thinking about the industry a lot. So you try to bridge the gap between the academic to the industry applications. Lots of the things is really kind of looks like overwhelming to us, but I think we make a great achievement, because probably 80 years ago, we still thinking media forensics as we talking about the fingerprint, we talking about the JPEG compression, etc. And right now, we're focusing on the deepfakes, because this is currently will be exponential increase in social media platform, this kind of thing. I completely agree with you that I called it active, kind of the active technology, and I call detection kind of the passive technology. Watermarking, sometimes we can use that. For example, FBI gets some evidence. They can put the watermarking everything from the camera to the whole process. They can use Adobe tools to mark all the provenance, etc. Yep. But most of the applications, let's see, probably 95% when we see in the social media platform, we don't know the whole thing. We don't know where it's coming from, who manipulated it, etc., etc. Then that passive sensing is really, really very, very challenging. And I know academics have a very good achievement to detection rate can reach 90% and even higher with a given environment. But I also know that when we apply that to the real world and the testing sample is not good enough, so the training model cannot cover all the case.
Yes.
So let's make the real world application software is very, very hard to develop that. So lots of the things we can think. Let me see. Before we talk, I think I'd like to ask for the audience, do you have any questions?
Yes, this is Yu Young from NIST. Thank you so much for your insightful presentation, because I benefit a lot from your presentation. My first question is the DOT application. Is there any age limit? Because I wanted my son to.
No. There's no age limit.
I have a 9 years old. I would like him to play with the DOT to see.
Sure.
Yeah. Send us the link. Yeah. Sure.
Well, you can just find it on App Store. It's on App Store. Just look for Deep Cover. Is there. So yeah, the game is designed to be fun and entertaining, because this is really designed for older adults who are not. So the project is called Deceptive Awareness and Resilience Training. So the deceptive causing most of the problem for us, but the common users on social media. A lot of people simply do not know AI have the capacity of changing the contents they're watching or hearing. So I think that's why we use a game as an accessible approach to improve the awareness. But it only scratched the surface, making people understand, the situations there, that, this kind of manipulation can happen. But, the resilience part, we use the learning platform so that the user will get the extensive information about each of this topic. Now, the game itself is designed, but I mean, everybody can play the game. It has a theme of in the 1970s, the spy movie. So the theme is you as a player infiltrate into an evil organization that using various kind of scams and deceptions to gain money, gain influence, or you steal use other users' identity, and you the player is a special agent, infiltrate into that organization, learn their trade, learn their secrets, and then help the other people to better prepare for them. So if someone is okay with some vintage movie like James Bond or Doctor Who theme, then you can play it, you can enjoy it. But inside the game is all like a little like a Wordle, connecting circles, those kind of mini games. So it's fun, and it's designed that way. Yes.
I'm glad that someone is doing this. So thank you so much for the effort. Actually, my next question is a little bit more serious than this question, but you mentioned about many good things here. But I just want to see what your insight on. Okay, fake or local fake is a problem, but we look at the problem as a harmful impact from the fakes, right? I mean, misinformation or disinformation can be generated from DeepFakes tool or generative AI model tool or human, right?
Yeah.
Do you have any insight on that problem? Do you have any thoughts on this? To why we're doing DeepFakes? And then, associated with the harmful impact from the DeepFakes, why we are so focused on deepfake detection instead of focusing on harmful impact, regardless what context out there, So.
Okay. So I guess the question is, why the focus on AI-generated fakes than manually generated fakes, right?
I mean, regardless what content, digital content we have, right? So, is there any reason we are, focusing on harmful impact on deepfake rather than just general digital content, that give us some influence, harmful influence?
I share the same. I guess I'm sharing the same feeling with you, because when I started working on my when I started my grad school, that was 22 years ago, 2001. I work in this area. It's already called digital image forensics, and the topic back then was Photoshop. So Photoshop the image. So throughout this 20 plus years, I've been seeing, the change of tools. AI just becomes much more handy tool to make falsified media, and you basically can scale up your effort. But what has not been changed is the intention, right? People make modified images. They want to spread some underlying messages, and those messages are meant to mislead or influence people. I think that has not been changed. So in that spirit, I totally agree with you. There's no reason to pay more attention to AI generated fakes than manually generated fakes. But I think the reason that this got so much visibility, publicity, is because we're basically riding the wave of AI. AI is the catchword on the street, and everything related with the AI will get more attention, right? So I'll say this is, sometimes I think about this is bad and it's good. Bad in the sense that, this is really, making the problem harder, because the AI models are like a human grow, and it basically cutting down the threshold for somebody to make a convincing fake. On the other hand, it's good because, I waited for 20 years for one day my research got some attention. And I think, that this is actually good for the community, because without this deepfake spotlight, I think we're, just looking back, when we started, not even like 20 years back, but when we started the Media4 program 8 years ago, Media4 program, supported by DARPA, there are only a handful of people in the world actually working in this area, right? We're sort of like an outcast from all the major research communities. Papers are not accepted by computer vision conferences, or, not even with image processing community. But these days, you see papers on deepfakes everywhere. Every major conferences will have some paper on this topic. So I think by that is actually doing a good service for the development of this community. So I think there's a historical reason why, deepfake just kind of steal the spotlight. But I mean, so far I don't see, other than, a little bit annoying, that, ignore everything developed before that. But I think it's, it's doing us more good than bad. Yes.
Thank you. If someone else has a question for.
Yeah. Any questions?
Yeah.
Sui, I think we can do it offline
Sure.
later.
Sorry, I don't want to
have
take
a
too
lot.
much.
Yeah.
Yes.
I completely agree with your idea, and I do want your advice on some of the points. Yeah, let's do it offline.
Sure. Yes.
Okay.
Thank you very much. Thank you for having me. Yes. All right.
Yeah, thank you. Thank you for such a wonderful talk. Oh, by the way, could you share the slides with the public, or you can share with me? Let me know. Yeah,
sure.
Which way you want.
Yeah, I can. I mean, that's absolutely.
Very helpful. Yeah.
Okay. Thank you very much. All right.
Yeah, thank you.
Have a good day.
You too. Okay.